Technology in Focus, highlighting the amazing research and technology that are open to investors. Learn about it here at the UNT Murphy Center for Entrepreneurship and Innovation.
I'm a Regents Professor in the Computer Science Engineering Department at the UNT. I've been in academics for nearly 35 years. It's 15 years at the UT Arlington, and then in the last 20 years at the UNT. I came here as department chair and started the computer engineering program. So I was the person who moved the computer science from College of Sciences into College of Engineering. But I have been working in this area for computer architecture, designing new types of computer processors, CPUs, and so on for the last 3 decades. I've published more than 200 papers, and I have 20 PhDs graduated and about 40 masters graduated under my supervision. So I have extensive background in this area. We are looking at artificial intelligence and machine learning problems. These problems have been now investigated in many different devices and environments, including very small devices like in a camera so that we can recognize faces, or in smart speakers to recognize voices. Right now, the smart speakers send all the data into the cloud to resolve the speech understanding, but we would like to embed them right in the smart speaker itself. These problems are pretty complex, so we need to have technology which is very efficient and solve the problems as quickly as possible and don't consume too much energy. One of the interesting features is most of the input data, like images or speech, contains a lot of zeros. Or you can make small values into zeros, so you can improve the number of zeros in the input. The advantage of having more zeros is you don't have to do a lot of multiplications and processing. However, you want to represent that data as efficiently as possible. There's a problem with storing the data very efficiently because retrieving the data requires more complex computation. So what we are proposing is some new ideas on how we can improve the efficiency of small processors in dealing with these data representations, which are called sparse data representation or compressed data representations, where we only store non-zero values and do not store zero values. But we need to understand where the zeros are, where non-zeros are, and that's where the complexity comes into. So what we have done is propose a separate small hardware, which we call Hardware Helper Spread, or HHP, that is delegated the responsibility of resolving all the addresses and locations of where zeros are, where non-zeros are, and provide that information to the main computing device called Central Processing Unit, or CPU. So CPU doesn't have to deal with these complex resolution of addresses. Addresses are very simple computation, where the CPU has to do very complex mathematical problems like multiplications, dealing with fractions, and those computations require a lot of hardware, a lot of energy. But if you ask the CPU to do the address resolution also, we are wasting that power. There are other solutions, but most of the other solutions are designed for high-end computers, not tiny devices, what we call embedded devices. So our technique is specifically targeting very small handheld devices or devices which are embedded in other systems. So there are very few proposals to address these issues, because we have to not only worry about the efficiency, but we want to make sure that our device does not take a lot of energy, because otherwise you have to recharge your devices very often. So we did not want to do that. The other key distinguishing feature of our technology is flexible. So if somebody comes up, say that I have a different way of representing my data, my sparse data, our device can be programmed. You can change our device to deal with any new type of format, either known at this time or some new formats that may be invented in the future, our device can deal with. So that flexibility does not exist with our current solution. When we are dealing with the computer chips, computer devices, we at the university do not have the capability to fabricate those. So what we need is a company which design CPUs like the Texas Instruments and Qualcomm, any of those companies which actually make chips to take our ideas and lead to a commercial product. So we are primarily doing simulations and show our idea how it works and give our design so somebody else can actually implement. So we definitely need a commercial partner, or we can just license our technology in terms of our idea, what we are proposing, and then also detailed design, but not actual implementation.